All right. Now, is there a way for us to use this to solve for other variables? And yes, actually, there is definitely a way for us to do that. Okay. So one thing we've been doing so far in all of our practice problems is we knew our starting and ending points. Okay. What if you only had a certain amount available of energy? Okay. This brings us back to our previous parts of this unit where a chemical reaction would run and it would only have a certain amount of energy it could release. So what if you did a chemical reaction and that chemical reaction released 4.97 kilojoules of energy, okay, into a solid block of lead, okay? Seems kind of weird, but let's say it happens. So if that reaction had this much energy to release and a block of lead was warming it up, okay, we should be able to figure out where will that lead end its temperature, okay? So we have 85 grams of that solid. We have 110 degrees Celsius lead to start off, so it's pretty warm already to go, okay? What's that final temperature of the block? Now, things to think about. Will it still be a solid, okay? Because lead is going to melt at some point here, and is 4.97 kilojoules enough energy to warm it up to its melting point and melt it? Or does it just warm it up and it runs out of energy before you get to the actual point where the lead melts? That we don't know, okay? So because of that, we have to take this thing piece by piece by piece. So what we're going to do is we're going to figure out the energy it takes to bring the lead from its current temperature to its melting point and get an answer, whatever that energy is. If that number is less than 4.97, then we know we got there, okay? We can subtract it, and then we know how much energy is still available to keep going. Then we can go to the next step and say, well, how much energy is it going to take to melt the lead? Solve for that, and then compare it back to the energy that's left, and basically take it piece by piece by piece, okay? It's kind of like going to a store, right? You go to a store, and let's say you have $497 in your hands. That's all you have. You got cash, $497, and you're going to go shopping, okay? You go into one store, and you buy some stuff, and the stuff that you buy, if it doesn't, use up all your money, you can go to another store and buy more. And you can keep doing that until you run out of money. Same idea here, just each leg of the pathway is one of the stores you're spending your money in, okay? Once you run out of money, then you can actually backtrack it and say, okay, I can't get past this point, so I can solve for that very final temperature, all right? All right, so if we do get past the solid phase of lead, we are going to need the specific heat capacity of liquid lead, okay? Because the specific heat capacity of solid lead is in our table again. So if we need to get to the liquid phase, here we are. It's 0.234 joules per gram degree Celsius. We're going to need that thing as we move forward, okay? So we're going to work our way through this thing, and we're going to see what it takes step by step by step, all right? So pause the video here. Tackle this thing if you can. Do your best at working your way through it step by step, and let's see if you come up with an answer. All right, now here we go to solve this guy, okay? So lots of information on the screen, but let's take a look at it. So first thing, we have a total of this many kilojoules of energy to use, okay? So we're going to break it down step by step, see how far we get. First of all, we have the 85 grams of lead. We know the specific heat capacity of lead was given off of our table, okay? That was 0.128 joules per gram degree Celsius. The melting point of lead was also on the table, was 327 degrees Celsius. From our starting point, which was here, to our melting point. So if we had 85 grams with a specific heat capacity, it changed this much temperature which brought us to the melting point, we would use 2360 joules of energy, or 2.36 kilojoules, okay? Now, we go to the iPad. That means I was right here, and I had 85 grams of lead, and I was at 110 degrees Celsius. So the first leg of this thing brought me up to 320 degrees Celsius, all right? So that was leg one. This is what we just solved for. This leg took away 2.36 kilojoules of energy, okay? Now, at this point, it's got to melt, so it won't warm up anymore. So now it's going to melt and use a certain amount of energy. And then that would be my part two. If we have enough energy, we might even warm it up some more after that. part 3. Now, we don't know if part 3 is going to happen yet or not, okay? So let's do a check and see. So to melt it, the Q value is our heat of fusion times the moles. So my heat of fusion for lead is 4.77. To get times my moles, I get 1.96 kilojoules, okay? Now, we've used 2.36 kilojoules. So we had 4.97. So 4.97 minus 2.36. We've used another 1.96 kilojoules on part 2 here. 1.96 kilojoules on part 2 here. And that was able to melt the whole thing. These two numbers added up are less than 4.970 kilojoules. So this plus this gives us something a little less than that. Now, if I subtract them, 4.97 minus these two numbers, okay, we have 0.65 kilojoules left, all right? So now I have it in a liquid phase, and I have 0.56 kilojoules left. Now, I just know from experience that if I'm going to take liquid lead, heat it up all the way to a point where lead starts to vaporize, it's probably going to take a lot of energy, okay? So having less than a kilojoule of energy left, oh, there should be a J in there, means I probably don't have enough to go all the way to the boiling point of lead, all right? Knowing that, what I'm going to do now is say, hey, what's the final temperature I can get with this much energy? So I'm going to flip it, okay? And I'm going to convert this back to joules and say, hey, if I have 650 joules of energy left over, remember, I am right here right now. I'm at this point here, and I have 650 joules to use to start working my way up this line, okay? If I have these 650 joules, I'm going to say, well, how far can I get? I know my mass. I know the specific heat capacity for lead as a liquid because that was given in the problem. Okay, not on the table. This was in the problem. So now I'm going to flip it, and I'm going to solve for that final temperature, which I can get. Do the work, and I get 360 degrees Celsius, which I can then double check just to make sure I wasn't wrong. I can go back to the table and say, okay, 360 degrees Celsius is the number that it tells me I can get to. All right. Now, is that below the boiling point of lead? Which it absolutely is. It's way below that. Okay, we only got another, a few degrees here warmer. Okay, which means my final temperature then with that energy is 360 degrees Celsius. Okay. Now, questions you might have: what happens if you run out of energy halfway through the melting phase? Well, then you know your final temperature. You didn't melt all of it. Okay, so it's possible that you could have run out of energy in the middle of this phase right here. So if that's the case, then part of the lead would have melted, part of it would not have melted, all right? In fact, you could figure out how much, all right? So you could do a simple ratio and say, well, if it's going to take 1.96 kilojoules of energy to melt all of it, and let's say, for example, you only had 1 kilojoule, well, 1 over 1.96 is about half, so about half of it would have melted and about half of it would have been still solid. In either case, it all would have been the same temperature still, okay? So that's where the complexity of these problems come in, is you actually can flip the scenario like we did in this problem here, all right? Now, there's additional practice for you. So there is a worksheet number 4, which has a whole bunch more practice on these that works your way through that, okay? I would highly advise you working through that because the bulk of the assessment for this part of thermodynamics is going to be setting up these scenarios, okay, and then running through them mathematically. So it really is a very heavy mathematical scenario in terms of solving for these things. All right, guys, that is it for this lesson. Thank you.